This is proglangcast, episode 8. I'm Steve Thames,
I'm Christopher Augustus.
and we are here to talk about our alternative to the Hello World program, which we call Bye Hello World. And today we're going to talk about a version written in Erlang. Bjarne Docker was the Planck owner of the computer science lab at Ericsson. He started it in the early 80s. They actually didn't set out to create a new language, but that's what they ended up doing. They were evaluating a number of different languages for the problems they were trying to solve, like concurrency and fault tolerance and high availability. And they ended up saying, well, we're just going to sit down and write a new language. And then they decided, well, Erlang is already a unit of measurement in telecom, so they'll call it Erlang. Erlang is a functional declarative language originally written by Joe Armstrong and Robert Verding and runs on the Beam, which is a virtual machine. So the Erlang compiles down to a bytecode, which runs in the Beam. The original name of the Beam was Jam, which is Joe's abstract machine. That's what it was called. And that was written by Joe Armstrong.
So then Beam came in, and it's B is for, I think it's Bjorn or Bogdan, because I guess right. one of those two guys rewrote the Jam.
Bogdan was the original guy, and Bjorn is the guy who's doing it now.
And they both begin with B, so that works out.
Right. Let's go ahead and take a look at the code that's been written for
Yeah.
this. Okay.
So I do have one question. I don't know if you dug into this, but I've seen a couple of videos with Joe Armstrong talking about the work that he did. And I think he mentions that Prolog was a big influence for his design of the language.
Yeah, but there was more than that. I watched a video, Bjarne Docker's How Erlang Got Its Name. In it, he talks about what they were doing back in the 60s and 70s and when he was working at Ericsson and the problems they were trying to accomplish by working on signal passing and working in assembly language, communication between disparate processes, things like that. And it's very interesting to listen to him because there are problems that we deal with today, but with the explosion of business data processing, you really don't run into them very much. It's only in these environments that are really real-time critical that you would run into the kinds of problems that they were dealing with as a regularity back then. A lack of resources, a need for fault tolerance. Obviously, we have a need for fault tolerance now, but fault tolerance in a real-time environment.
All right, so what are we looking at? Oh, do we want to run it first or look at the code first?
All right, well, we can absolutely run it. So now we're running in Windows Subsystem for Linux, WSL, running Ubuntu on my Windows machine. There is actually a run script for this one, which I'll show you here. What it's going to do is it's going to check to see if the OTP is in your path. That's the runtime environment for Erlang. So if it's not in your path, then it's going to go out and see if it's been installed locally. If it's not, then it'll install it locally. I don't recommend doing this. I actually recommend, if you want to run this program, to install it in your Linux environment because this takes a very long time. At least it did in my WSL. After 30 minutes, it was still not finished with the configure process. Yeah. So that's the run script. And we're actually going to use that to run this.
The nice thing about the run scripts, though, is people don't really have to know how they work. They could just say /run, and it tries to auto-magically, at least most of the ones we do for Bye Hello World, auto-magically grab it if it's open source, build it locally within the Bye Hello World directly, and then run it from there. But as you say, if it finds that it's already installed, it just skips that part.
Okay, so we're going to try running this in the shell. I'm typing /run 5.
Okay, so you entered 5 as the starting argument. World hello 5, 4, 3, 2, 1, bye.
Right.
Okay, looks like it works.
Yes, it does. Let's try running it without any parameters.
Start time looks a little slow.
Yeah,
Countdown.
You have to ignore that in my computer. My WSL is slow.
Is it your WSL?
It seems to be where it manifests itself mostly. If I put in just run with, say, XXXX, then it'll come up and tell me that it is, this was the other Invalid countdown
Invalid countdown.
XXXX.
Oh, you put it in quotes. I've noticed that on some of the other languages, we're not putting the countdown in quotes. So got to decide what the bona fide spec should be, I think.
Well, actually, the reason that they're in quotes is because only if they're strings, and it has to do with how Erlang does output formatting, which I will show when we take a look at the code.
Oh, so if you enter like a -1, it won't be
Right.
in quotes.
It will not be in quotes
Oh, that's interesting.
because that's an integer. Yeah. I thought it was worthwhile to demonstrate that.
Oh, yeah. Okay. Huh. Interesting.
And I can put in 0.
0.
In
0
which
is
case it'll
legitimate.
just, and I can also run, now if I was running this is actually running through eScript, which is the scripting engine for Erlang. Normally when you run something through the Erlang virtual machine, it will be compiled down to bytecode using the Erlang compiler. So if I were to compile this, I would run the Erlang compiler,
which is
BBHW,
ERLC.
ERLC space BBHW.ERL.
Okay.
And that's going to compile it
And it is taking a
soon
little
here.
while.
It's going to be done.
All right.
Okay, now it's done.
So what did we get from that compiler? What did it do?
We got bbhw.beam.
So .beam is the binary.
It's the bytecode, yes.
It's the bytecode. So the beam, like the JVM or like the net, .NET CLR environment, they all take source. They generate intermediate bytecode, which is meant to be platform portable, and that's what actually executes when you run these things.
Mm-hmm. Okay, so now we've got our code written. It is compiled down to the bytecode, and we can actually run it from the command line now. I'm going to run it without running it in the shell. So we're going to just run an Erlang. We're going to say no shell.
Oh, you have to say no shell or it goes in the shell.
It's going to load the shell. So I'm going to say without the shell, I'm going to run BBHW. I'm going to run the main function in BBHW, and I'm going to pass in one parameter, and then I'm going to say,
oh, wow.
That's what you would do if you're going to run it in the shell. And you're going to run it without loading up the shell. You're just going to run it in the beam and then exit the beam.
Okay, so let me read this out. Erl space dash no shell space dash s, which is, what's the dash s mean?
That is a signal. It's a signal to the initialization routine to load up the BBHW module. And then so when I put in the -s BBHW, then I'm going to say the function name inside BBHW and any parameters I'm going to pass.
And then the second, so there's 2 dash s's. So you've got like one and then another. And you have to tell it to stop?
Yeah.
What if you don't put that in there?
I'm going to pass in the -s init stop, and then that will execute from it will exit from its running environment.
Wow, the run script's a lot easier.
Yeah, the run script is a lot easier, and
that's why we put the run scripts in there.
Well, actually, this is not. So this will run it in the beam, but not loading the shell.
Okay.
But this is actually running the bytecode, which is interesting because you'll probably see that it's running faster. And now this time we will run it in the shell. I'm going to load the shell. I just type in
So you
ERL,
just type Erl.
Right?
Okay, so we got shell prompts that came up.
And now I'm going to compile
OTP
it.
27.
The compile command inside the shell is just C, then left paren, BBHW. It's gonna default to .erl, so I don't have to do that, and then put in a period. So it's C left paren, BBHW right paren, period. We'll compile it, and I get my response is okay. And now I'm just gonna say BBHW :main, specify. And I'm putting in BBHW :main left paren 5 right paren, and a period, because that's how we call it from the shell. When you're shell, it's a REPL, so you're actually typing in commands directly. I can put in arithmetic command. I can do anything I want, but I can run any of these functions. Like for example, here's running it the BBHW :main.
Okay, looks the same.
I could also do an IO : format.
So you can enter any legal Erlang expression here.
Mm-hmm. That's
Okay,
exactly right. And you'll get a response. You'll get an okay response back.
gotcha.
All right, so if we look over at the code, and I'll try to answer some of your questions about this. So the first one is dash module left paren BBHW right paren period. That
Yeah,
terminates the statement.
I
Okay.
think that's one of the things a lot of people don't like about the syntax. Have you ever seen any other language that terminated a statement or expression with a period?
COBOL.
Oh,
So when we look at the language in Erlang, it's a declarative language. It is a functional language. It has no immutability. And it's not like F# where you can say, make this mutable. In Erlang, you can't. There is no mutability in Erlang. You're always writing things functionally. The export statement specifies what functions are being exported from this module. And as you can see, it's a list, and I specify the two names main/0, meaning main no parameters, or main/1, so main and one parameter. So that's
so
what's
that's
being,
how. So do you have to say both variations? Can you just say main and it would?
no,
Because I noticed you've got 4 patterns, but you've got 2 exports.
that's right, because I have 3 definitions for main with one parameter.
Ah,
The first definition of main, that is terminated with a period. But you notice the second definition of main is not terminated with a period.
so semicolon.
It is terminated with a semicolon. There's a reason for that. It's got a single parameter, but that's not the only declaration of main with a single parameter.
Oh,
So that's why you terminate that one with a semicolon.
because there's more mains below.
There's
I
more
see
mains with a
declare.
single parameter below it. Because a single parameter is defined as 2 brackets, you're specifying exactly what it's going to be. Like, for instance, if I put in main 1, well, that's valid. If somebody passes in main with 1, that's what's going to be called.
So you could put another main declaration there with main 1.
Yes.
And that's pattern matching, right?
Mm-hmm.
What it does is depending on the argument it matches it against all the possibilities.
As a matter of fact, most of Erlang is about pattern matching.
And so depending on how you call that main with a single argument, you've basically said, here's 3 different patterns. And if it matches, whichever one it matches is the one it's going to get called. Is that right?
That's correct. I could put in a literal. I could put in main left paren ABC right paren, which that's called an atom, by the way, in Erlang.
An atom is what?
When we ran the IO format, or when we ran BBHW main, you notice it responded with OK. OK is an atom. It's a literal. They must start with lowercase letter, and if it's got spaces in it, it has to be surrounded by quotes, single quotes, in order to be considered an atom. The next definition down is taking in main with the parameter named arg. Arg is a value, and values or variables are always start with a capital letter.
So it's not looking for somebody passing arg. It's
No.
saying whatever you pass, this is the binding or the alias for what they passed.
If arg was all lowercase, then it would be a pattern match to lowercase arg. Being, if I said, for instance, main OK, then it would specifically be for somebody passing the atom OK into the
so it only matches in that case if OK is actually passed. But in this case, because it's uppercase, you're right. I guess we shouldn't use the word variable, because in an immutable, where everything's immutable, it doesn't vary, right?
No.
It's a value.
It's a value.
But it's the arg is the name bound to the value. It's not the value.
That's correct.
Okay.
This one has the qualification afterwards, when. This will be the pattern to match when arg is an integer. Integer is a primitive that just checks to see if the value is in the subset of integers. The next definition of main is main arg, and there is no qualification.
So effectively, it looks like those 3 main definitions are essentially one statement.
They are one declaration.
They're always ended by a period.
Mm-hmm.
In some cases, it's one line. In some cases, it spans many lines. I mean, as far as it wants to go until it finds that period, right?
That's exactly right.
Okay.
So those are the different definitions we have for main. Let's take a look at why. We can call this from running it in the scripting engine. We can call it by running in the Erlang shell without actually invoking the shell. We can run it from the command line as we demonstrated, and we can run it from within the shell. So in our first definition or second definition of main with one arg, when we're looking at whether or not it's an integer. Now this will happen when you call bbhw main from the shell and pass in an integer value right here as the parameter. When you call this script with erl-no shell -s bbhw main, and you do not pass any parameters, there will be no parameters, which is why we have main and no parameters. If you call
not even an empty list. It's
not even
literally
an empty
like
list.
it's zero. It's main zero. That's the definition of main zero, right?
That's exactly
no
right.
arguments at all. Okay.
When you call this with eScript and you don't specify any parameters, it comes in as an empty list.
So it's going to give you the list no matter what, and that qualifies as main one because that's still an argument. It's an empty list, but it's still an argument. This is really different than other languages. Like I'm thinking already, without looking at the details of mains, just the fact that you've declared four patterns of main. Well, okay, two different functions, but for one of the functions, you got three different patterns for the same function.
It's mostly pattern matching. Let's talk about that. We have our isInteger.
Main arg, when isInteger arg. So we've already realized that's part of the matching pattern. Is this guaranteeing me that the body of that will never get called if it's not an integer? In other words, the checking of the arg being an integer is going to happen at the point in which it decides to call rather than inside? I mean, is this basically saying I can now safely assume arg is always an integer?
Inside there, yes, you can.
And so that's enforced by Erlang itself.
Yes.
When you call from the shell, argument can actually be an integer, not a string representing an integer.
Yeah. All right. So bbhw : main and pass in xxx. Comes back invalid countdown. I can pass in bbhw : main 0. That's coming in as an integer.
Got it. So when you put the 0, it went into the first pattern, when is integer.
That's right.
When you went xxx, it never even went to that function.
Never went there.
Because it doesn't match the pattern.
So I love the pattern matching aspect, but it does present some interesting challenges because Erlang is a very limited language. Okay, it's limited in its primitives. It's designed specifically to be small. Like for instance, you look at these, the when statement, for instance, I can use isInteger here. I can use isList. I can use isAtom. I cannot use this. Okay.
You can't use that in the function pattern.
The
function signature pattern.
In the main when pattern matching, I can't use that.
Okay.
I can't use a function definition from somewhere else. I could say like main arg when arg equals 0.
So just some expression.
Some expression I could do.
Okay.
So looking at the first definition of main where we're saying isInteger, I'm executing a case statement. Now in the case statement, I'm calling a function. Is it good is very simple. It comes down here and it says, is I greater than or equal to 0? That is a Boolean condition, and it's simply going to return true or false. If it returns true, then my next thing is going to be to call run, specifying the integer argument. If it's not greater than or equal to 0, then it's going to call isBadArg. And isBadArg is going to call another function called isNotGood, specifying arg. And here's isNotGood right here. And you made the comment about when I put in a string, it's going to surround it with quotes. And when I put it in an integer, it's not. That's this format string right here.
The tilde lowercase p.
I mean, I think of it as pretty. Print it pretty for that data type. So if it's a string, it surrounds it with quotes. If it's an
Oh
integer,
yeah,
it
yeah,
doesn't.
yeah, yeah. Scheme has a similar sort of distinction.
Right. So that's
That
what
makes
the is
sense.
not good does. So when it passes in the is bad arg, it calls the is not good, passing in the single argument, so it'll print that error, and then it calls the run as if no parameters were passed.
I
And
have a
that's
question about that case, that first case statement
right.
under main arg when is integer. So that just looks like an if statement to me. It's just
Yeah,
a true condition, a false condition. Does it have
mhm.
to be case? Is there an if statement?
There is. I'm going to get to that one in a minute. So as you pointed out, you've got the case, is it good? And if I wanted to
Of
have another, let's say if it was possible for me to have, like I could have replaced this, for instance, with this.
false underscore? Underscore.
Just underscore,
And
which
which
is the
means what?
which would be the default. I mean, every other value.
Oh, that's, oh, okay. That's, yeah. Yeah. Just,
Anything that's not true. The last main function was the one where because I was trying very hard to not use if, because I
really?
had read this and I think, well, if is bad, you don't want to use if statement. Case should handle everything. But then I was looking at the different ways that these values could come in, and it made it very challenging because remember that the single parameter of arg, it can
Uh-huh.
be a list, it can
Right.
be an atom, it can be a string, it can be an integer. The integer condition is handled up here. So I
Well,
needed to
can't,
handle the other three.
or it's anything that's not an integer and not an empty list,
So
according to your patterns.
think of the way that you could handle that, right, with a
Uh-huh.
case statement. As I ran round and round with this, looking at this particular problem, I thought, okay, I've got a case where the is string I can call the IOLib printable list arg. It'll return true if the value is a string. Here's the tricky part. A string is a list. And if it comes in as a string, we call get countdown arg. Get countdown, it's going to try to convert the string to an integer. String to integer is going to return this. So a comma separated list inside braces says I've got multiple values in this tuple. The first one is going to be the integer value, and this is going to be a list of everything that couldn't be converted to an integer. Okay, so taking a look at this, if we put in, let's go back into the shell. And then if I run this bbhw main and say I put in 1 equals 2, that's going to be an invalid countdown. And what that would come in as is 1, and the equal sign 2 would be in that list. Okay, so that's what's going to be returned by string to integer. I look for, is there simply an integer value and an empty list? Then that's what I want. There are other values that it'll return. It can return an error string like you saw up here with get countdown, but I don't have to look for that because all I am looking for is an integer and an empty list. If we match this one, we call is it good. If it's not good, it's in this case it's going to mean it's a negative number. So we call is not good I. It's passing in an integer value, which so that the pretty print part down here in is not good is actually going to print it as an integer without quotes around it. Where if I said is not good S, which is what was passed in to get countdown as a string, then it would have quotes around it. Get countdown is going to return is not good. Is not good is going to return the string error. And the error string is checked for in our is string up here. Error is just going to call main, which is going to call run. If it's good, we return that value, in which case here we'll call run, and C indicates the count value. That's going to be the integer value that comes out of get countdown, and then we'll call run with that integer value. Now that's the is string condition. We have to check that first because a string is a list. And in the is list, we simply pass back to main with the first argument in the list. And if it's an atom, then I'm going to call atom to list. Otherwise, everything else is going to call is bad arg. And that's done. So that demonstrates a case where the if statement is a better choice than the case statement.
can't you make two more patterns, one that's list and one that's atom, and make those separate implementations of main, just like you did with his integer?
Yes, you're right. There's more I could have done with the function pattern matching to simplify it, but I liked the way this read. So let's move on and take a look at what actually happens. So here we've got another set of pattern matching, a run with no parameters, a run with a single count parameter, and then we have the rundown, which actually does the sleep part of it. Here's your run, which is going to call run passing in read input. Here's your read input. Now this is the recursive one. And this calls something in the IO library called getLine. GetLine just simply takes a prompt parameter and will prompt for input. Any value that they type in, that will be assigned to line. Line is going to be bound to whatever they type in. The reason I couldn't put line up here at the top is because when I did that and I got an EOF, it came in to line as EOF.
Right.
So that's why I had to check for these conditions. The same thing with this tuple, error, comma, and anything else. That's what the underscore means. It's going to come on as a tuple with two values. The first one is going to be called error, again, pattern matching. The second one, we don't care. That's what the underline means. So I have to check for all three of these conditions. If it comes in as EOF, which is for some reason the IO system is returning an EOF. I think I did find a way to simulate that. The error I didn't find a way to simulate, but this is how that's going to come in. In those cases, I simply want to call read input again, which will again prompt the countdown. So if it comes in as EOF, it doesn't say invalid countdown because there was nothing that came in. If it comes in as error, it doesn't call bad arg or whatever is bad arg and give you that error message and then call read input because there is no bad argument. Same thing with the line feed. If the line feed comes in, that means they just pressed enter. So there is no invalid countdown. It just comes back up with countdown. Otherwise, everything else we pass into get countdown. And here we're stripping off the line feed. That's how you do that, as a string strip. And that's what I'm passing into get countdown. Get countdown is either going to return error. Now, again, everything's dynamically typed, which is why I can't check for I first, because I could be error. And we know that read input, that get countdown is going to return either an integer that was typed in, or it's going to return the string error.
Is that a string or is that an atom?
It's an atom. Yeah.
Okay. Yeah, I think what's confusing to people who haven't seen Erlang before is in your case statement, that line is equivalent to the underscore with the difference of you now have a binding to whatever it is.
Right.
Right. That's why you always have to put the literal values first. Because if you put a name, we'll call it a variable name. People are going to think of it as a variable name with an uppercase. Then that's a catch-all. It's just saying I'm going to catch everything, but I also now have a name you can use to refer to the anything because you have to print it out. You use underscore when you have no reason to refer to the catch-all, right? It just means everything else, and I don't care what it is. I'm never going to refer to it.
There is actually a really good video that describes, it's just a guy, he goes through and he just types all these different things to tell you about all these basic functions, the atoms, the terms, the values, how to use them all. He's very, very informative.
Yeah.
So I'll have a link to that when it talks about all of this. But yes, I agree, having a good, pretty thorough understanding of the difference in what these values are can be pretty important. If I put I first, then I could be equal to this atom error. That's what it could come in as.
Right, because it's a catch-all. It means anything.
Well,
you're just giving it a name. You're just saying anything, and I'm going to name it I. If you put it up top.
Well, yes, but get countdown. The anything it's going to return is going to be an integer. Otherwise, it's going to return an error. I know that's the signature of that function.
Right. I was just making the point you already made, which is you have to put the literals before the catch-all. Catch-all has to be the last thing because otherwise the catch-all will just pick up anything. You see what I'm
Unless you
saying?
can be certain of the signature that you're looking for, like this one. That was the point I was
Well,
making
that's
about this.
well,
I
okay.
could do
That's not
this here because this is the only, because I have this pattern match is the only one that I want. So
right,
I
but
don't have to look at the error conditions and stuff.
that's not a catch-all. The I catches part of the tuple. It basically says the first part of the tuple is a catch-all, but the second part of the tuple has to be an empty list. So
What do you
that's
mean by a catch-all?
well,
Because
in
when
any
I
of
think of a
these,
catch-all, I mean, I think of this one.
the underscore,
Yeah,
yes,
that's a
or
catch-all.
a that's a catch-all. So is a name by itself with nothing else. There's two catch-alls in Erlang in these case statements. The underscore says catch everything, and I'm never going to refer to it, so I don't need a name. I don't care. So underscore means I don't care. If you give it just a name like you did line and I, those are equivalent. Those are catch-alls. The difference is you can now use the name in the implementation.
Right.
A lot of people learning Erlang are going to trip up on. I don't understand. Like, is that a variable? Is line of what is line? Like, I don't see line anywhere. It's like, no, that's just the binding of the catch-all.
Right. And it can be bound to anything, a string, a number,
Yeah.
an atom,
But
anything.
in the case of the pattern you identified up above, where was it that had the I inside the tuple? Oh, right there. There is a catch-all for part of the tuple. So the pattern is basically saying it's got to be a tuple. The second has to be an empty list in order for
Right.
it to match. But the first can match anything, meaning it's a catch-all within the tuple. But the overall expression, the overall pattern is still a distinct pattern. So anything that's not a tuple is not going to match that. Or in fact, anything that's not a tuple with the second element as an empty list is not going to match that.
More importantly, the signature of toInteger is only going to return a catch-all and an empty list if it had a valid conversion. Otherwise, it's going to return, I think, the ERR or some other string, which I don't care about. The only one I care about is that it got a valid conversion and
Right.
there were no remainders. There was nothing after the integer. So I'm only looking for that one because I can match that one. I don't have to check for the errors. In the case down here, the point I was making is I can't do that because I only want the value that they brought in the line, which is going to be a string. So if it comes
Yeah.
in as an atom or an error, I have to check for those because the catch-all is going to catch all of it. The same thing down here. If I get countdown, I have to check for the error because it's either going to be error or it's going to be a valid catch-all value, in this case, an integer. So that's what this one is doing on read input. Otherwise, it recurses and calls read input again. Now that's interesting to me because of the discussion we had when we were talking about F#, tail recursion.
Mm-hmm. Yep.
Because it was a question that I had when we talked about tail recursion, and you made the comment, and I researched this. If the function is the last statement, if the call to itself is the last statement, then it's tail recursive. So it doesn't have to push more down onto the stack. It just replaces the values onto the stack as long as you didn't use anything else. If I didn't say like I plus read input or 1 plus read input, then it wouldn't be tail recursive. But the question was, does it have to be the last statement in the function declaration or definition, or just the last statement executed? And apparently, and although this is not clearly documented in Erlang, I did some research, and the consensus out there is that yes, that is tail recursive as long as it's the last statement. So all of these, since they are the last thing that can be called in each one of them, are all validly tail recursive.
As long as it's the last thing executed.
Right. As long
It
as it's
doesn't
the
matter
last thing
where
executed.
it doesn't matter where it appears in the body of the function, as long as there's nothing executed after that call.
If you didn't watch our F# video where we did talk about this, what tail recursive means, if you know anything about recursion, everything in your functions uses what's called automatic variables. It's stack based. So when you call a function, any parameters gets pushed onto the stack, the address you want to return to is pushed onto the stack, and then the function is called. And before the function returns, it pops off the return value and then returns. When we do something like recursion, that means that if you're passing parameters in every time, then you're going to keep passing parameters, and you're going to keep passing that return, so that it would literally unwind all the way back. Tail recursion means if I'm going to simply call the same function, and I'm not working with any literals or anything else in the function, like for instance, what would be a good example of that? You could even do it with, like for instance, if you have a function and say add 1, and you pass a value in that says the return value is 1 plus add 1, then that's not tail recursive, because it's got to pass a new value every time. It has to save those automatic variables that have been created inside the function. But if you don't do that, all you're doing, like I'm doing here, is just calling read input, no new parameters, and I'm not messing with anything that's been created inside this function. Then I can ignore any automatic variables that have been created. I can just go back to be just like it's the original call. It's sort of a replacement. That's what tail recursion means. Every subsequent call to the function is going to replace the original call in the stack. So there won't be any unwinding as you go back. You won't be returning and then popping the stack, and then returning and popping the stack, returning and popping the stack. You won't be doing any of that. What will happen is the final recursion, cursed down 1,000 times, it doesn't matter. It's going to pop that return value on the stack, and that's going to be the return of the original call.
Yeah.
That's fundamentally what tail recursion is. So that's what our read input method does. Our read input function, does is it simply takes in the line of input. So you can see the case statement here. All of the statements are separated by semicolons, except for the last. So then you have line, which does another case statement, and that does read input followed by a semicolon. But notice this, the I here, that is not terminated with a semicolon.
Yeah.
The reason is because there's never a semicolon before the end statement in a case.
Yeah, that always trips me up.
Yep.
When I'm coding in Erlang, I tripped up on this thing. I understand the logic behind the comma, the semicolon, and the period. I understand the logic of it. But there's times definitely where there's an awkwardness to it.
And it's interesting that you brought up the comma, because we haven't seen that yet, but we're going to see that one in a minute. But this end statement here, you notice again, does not have a semicolon, because it precedes another end that has the period. So that's something that will definitely trip you up. It tripped me up just like
I trip over it.
You up as well. Take a look at what happens when you call isBadArg. Because the way the routine works, we'll demonstrate that here. So I'm going to quit the shell, and I'm going to run X, which is going to be invalid. So if I pass in an invalid argument, what it's going to do is it's going to tell me that argument is invalid, but then it's going to go right into read input. So that's what isBadArg is doing. If the argument that gets checked is bad, it simply calls isNotGood, which is going to format the output, and then it's going to call run with no parameters. When I was putting this together, I thought to myself, well, I want the main function to be the one that actually does the work. But because of the way Erlang works, because of its immutable nature and how everything is based around functions, that really didn't make any sense. So what I ended up doing was setting it up so that main was the thing that would always just validate the input parameters. It would validate the setup of the routine, and the run is the one that would actually do all the work. So that's why when run is called with an empty parameter, the only time that's going to happen is if main is called with no parameters. So it's going to call run. It's going to get called with isBadArg when the value passed in was invalid. Those are the only two cases. And then it's going to call this run and pass in the read input to itself, which will call this next one, which passes in the value. And so that's called in a couple of places here. You've got, if the get countdown from what's passed in is good, then it's going to call run C. And the other place, I believe this is the only other place where it's done, right here, where it's going to call run and pass read input. Read input is going to keep doing this until it gets a valid value. and then it's going to do our IO format world hello, and then it calls our rundown function. And again, we're going to be talking about recursion here, because rundown, remember everything's immutable, is going to, this rundown C, and this is, again, we've got our pattern matching. Rundown 0, remember I mentioned before, is that I could pass in main with a specific number. That's how that pattern matching works. So when it hits 0, it's simply going to return, okay, we're good. Otherwise, it's going to call this one where it does the format of the value, sleeps for 1 second, and then calls itself again with one less. And eventually, it's going to hit 0, which will call this one, and we're finished. So this is going to be recursing again. Again, this is a valid tail recursion function, because we're just passing, we're not doing anything with any of the automatic variables or any literals inside the function. This is the only function here which actually uses the comma. The comma is what we use to separate statements that are going to be run sequentially.
Right. And whereas semicolon separates alternatives, commas are saying do this, do this, do this, do this, do this, and then period as I'm done. When there's semicolons, it's going to be this or this or this or this based on how it's structured.
When I look at this now, a lot of it I put together in order to demonstrate the different ways of handling these conditionals. It's one of the things I thought was of real value in BBHW, because this is actually a pretty good introduction to Erlang from the point of view of its syntax, how it handles values, and its immutability, and its functional and declarative style.
Yeah, exactly. Whereas if you just do hello world, you get no sense of what it's like to program in Erlang, because you're going to have one statement that just prints hello world. It's like, that tells me nothing about all of this. And you're right. I think Bye Bye Hello World is a good case, because as you point out in Erlang, you're not going to be able to do much in Erlang without dealing with its fundamental nature, which is this no mutation of values, pattern matching, its syntax, getting used to the semicolons, commas, and periods. You wouldn't have to deal with that in a hello world. You would literally just be like IO print hello world period. Mm-hmm. You wouldn't need a comma. You wouldn't need a semicolon. You wouldn't be dealing with immutability because you're printing a literal. There's no variables. Here you have mutation of a kind without mutation, right? You've got a countdown. You've got a count that's changing. And so you're using the functional immutable way of doing change of state, if you want to look at it that way. And hello world, there's no change of state. It does not impinge upon you. What it's like to program in that language is the whole basis for why the idea of the Bye Bye Hello World came up with. What's a small program, still small, ideally fit on one page. There's a lot of lines here. I got to admit, for me, it's hard. It kind of is like, it's got to be a shorter variation of this that still gives you the essence of what Bye Bye Hello World is. And not too much.
Probably. Right? I mean, first of all, for one thing, you could decide how you wanted it to run. If you only wanted it to run as a script, you didn't need all this stuff. It's just going to come in as a list of parameters, or it's not.
Well, there's some things you still have to do. For example, to me, the most comprehensible part of this program is the last part. Go to the very bottom. You're still going to have a recursive function for rundown.
That's right. You are.
Because immutability of values, it's the only way.
There is no for statement in Erlang.
There's no for loop where you can mutate a counter over the course of the loop. You're literally calling with a new value. You're doing a new iteration with a new value. You're not doing anything with the previous values. They're still there, or they still remain unchanged, right? If anybody had a reference to them. This is a garbage collected language.
Yes.
It's an interesting hybrid to me, because people who've never seen it before, coming from most of the modern conventional languages, there's like a very clear distinction between dynamically typed, garbage collected, versus statically typed, not garbage collected. I mean, I guess with Go and other languages, it becomes a little bit of a mix, but here's this weird hybrid. It's like, well, there's immutability, And if I was in Haskell, I'd have immutability, but then I've got all the static types. There's no static types, but there's immutability. I don't have for loops. I've got recursion, which is very much a Lispy sort of thing. But again, Lisps, there's no immutability in Lisps. So it's like it's almost like somebody took aspects of various languages and kind of went, I'm going to make a unique blend of here this from that and this from that and this from that. At least it
And
feels that way to me. As we start to explore the languages, we may see that.
That's exactly what they did. I'm going to put a link to that video that Bjorn Docker did to talk about it,
Yeah.
because it's really fascinating when it talks about how this language came together, how it became from all their research, going all the way back to PL360 and the assembly language work he was doing through all the different languages, including Pascal and Airy Pascal, and some of the ones that I hadn't heard of, but I'm sure maybe you've
not heard of any of the ones you just mentioned.
You know, well, certainly PL360 you have. PL360 was like PL1 or PLI.
No, I never heard of it before you mentioned it today.
PL1?
No, PL1, but not PL360.
Yeah, it's programming language 1. PL360 was something that was for the IBM 360. It was
the 360th programming language.
It was IBM's 360.
Now, I understand that's where it came from, but I'm saying before you came up with the name today, I'd never heard of PL360.
Yeah, I hadn't either until I saw the video. Like I said, I'll put a link to it in there.
An Airy Pascal.
I was just gonna but take a look at this. We were talking about Hello World and how it's really very useless. This is your Hello World program.
Right.
The whole thing. IO format Hello World. And
right.
The only thing that is going to teach you is that in order to write in Erlang, you have to call a module, a function in a module, and pass it a value, and then you can print it out. And that doesn't tell you anything about the language.
I got news to you. That's actually legal syntax in a lot of languages except for the period. like a namespace, a function, parentheses, and a string.
Oh no, I know.
This could be the program in many languages. Right. You don't know that's Erlang. I mean, the period maybe is the only giveaway.
But the truth is, this doesn't even tell you, like a C program, a C Hello World program would at least have a main method in it, and then it would have braces, and it would have a printf. I mean, at least you would see that it's a function. It takes parameters and has braces, and you really don't get much of that here. You don't get any knowledge of the recursion. You don't get any knowledge of the pattern matching. You don't get any knowledge of the immutability. Nothing comes from this version of Hello World.
Yeah, and I realize that we're kind of patting ourselves on or I should say, I'm patting myself on the back way too much here. But that's the point about Hello World, is it always shows you the scaffolding to get to a program. So you're right. It's like in C, you've got to have like a lot of people when they want to rag on Java, they always show that it's static void, static int void, public static int or public static void. I don't remember exactly what it is, but it's like public static void to do something, and like, oh my God, all the ceremony you have to go through. And Hello World, I think more than anything else, I mean, it doesn't really do anything other than to show you what ceremony you would have to go through to do anything. But then it won't show you how to do anything. It just shows you the ceremony you have to do to get to doing anything, right? And here you're saying, okay, for Erlang, there's not a lot of ceremony for that, but I still have no sense what the language is like. In a language like C or a language like Rust even, right? Rust, you're going to have to say cargo, new, something. They're like, here's all the ceremony to get to where the meat of the actual program is, and that's it. We're not going to show you what the actual programming is. We're just going to show you the scaffold, the stuff that gets you into the club, but we don't show you what it's like to be in the club. We just show you the lines and the ropes and the bouncers you have to get by, and everybody before you can have any fun. But otherwise, you have no idea what's like inside. What's your
Well, I can tell you that I really, what I find that I like about this, I really enjoyed it. I'm, as I look back on it now, I really enjoyed playing around with all of the pattern matching, and it's actually pretty simple. Once you get past some of the syntax stuff and you find yourself, I mean, it forces you to think, how can I write this recursively? How can I write this more efficiently? How can I write this in such a declarative way that I've managed all the conditions that can come in, like the main method, which is handling all those conditions? Did they run it from Erlang without the shell with no parameters? Did they run it from Erlang without the shell with parameters? Did they run it from eScript without parameters? Did they run it with parameters? Did they run it from within the shell, calling the function directly? I mean, I really enjoyed having to solve that problem and going in through how can I do this by pattern matching? And you've demonstrated a couple of ways that this could even be further done with just pattern matching to the functions. I disagree about the concept of don't ever use if. You know what? I'll bet you that there is no more overhead in this if construction than there would be by doing a case is string, then case get countdown, then then otherwise, if it's not that, then do an is list. It would be a lot harder to read and gain you nothing. That's my conclusion.
Are you throwing down the gauntlet? You want me to take a refactor stab at this and see if we can get rid of the if and make it just as readable?
Well, you're welcome to do that, but let's not do that today. I played around with this. I tried working with the cases and mixing and matching them, and it was pain in the ass. And so that's when I said, I'm going to look at the if statement and see what it really is. And I thought, you know what? This works great. I'm much happier with doing this than having to do these cases inside of cases and inside of cases. And I found the other way was, so I'm going to disagree with that. While I do agree that the case statement is probably what you're going to use most of the time. So I don't by any means advocating being crazy about ifs. Okay, isolate your conditions, use case statements as much as you can. Hell, use the function pattern matching as much as you can. But you're not going to gain anything by working so hard to get rid of if you're dealing with a situation where case results in case, then case, then case, then case, then case, then case. Your code moves out this way and becomes a lot harder to follow. I mean,
well, I agree. Pyramid of Doom is not the solution to anything. In fact, I have an Erlang script that I wrote that has a terrible Pyramid of Doom in it. And I put a comment in there saying this is horrible. It needs to be redone. Maybe the if is the solution. Maybe you're right about that.
Well, it might be worth looking at very least. I mean, like I said, for me, I'm always going for clarity.
The one thing Erlang gets hit on more than anything else, it's in some ways, it's the reason for the existence of Elixir, the syntax. What do you think of the syntax?
Well, it's funny that you mention that because I have taken a look at Elixir briefly. And my first thought when I looked at it was, why? I couldn't think of a justification because, listen, for me, I like brevity, okay? I mean, I know in a case like this, it might not look like it. I'm always going for readability, so I'll sacrifice brevity for readability on some occasions. But for the most part, I like brevity. I like something that it does its stuff. It's not very verbose. Verbose languages like BASIC, like COBOL, that were designed to
Did you ever program in COBOL? Have you ever written COBOL?
Yeah, in fact, there is still a ton of COBOL work out there. A friend of mine's father is still doing COBOL. He actually just got called back.
Apparently, you can make a lot of money doing it because nobody knows it.
There are people still doing
a lot
it.
Of good.
Hell, HP had one program that had gotten so far out of hand where they asked me to convert it to C, and 1,000 pages of COBOL went to 40 pages of C. My point is, I like brevity. To answer your question, when I look at this, you talk about the question of syntax, I'm seeing the colon, the semicolon, or the semicolon, the period, and the comma, and the lambda construction, the right pointing arrow. I mean, that's the extent of what I'm seeing. In terms of the syntax, I think it's real easy.
So you like it?
Well, yes. So far, I've written one small program in it. I actually thought about it. I thought about trying to write a concurrent one where maybe one thread, one process handled the input and the other process, handled the countdown, something like that. But I thought, no, it is supposed to be an introductory thing. Let's not get too complicated.
Well, no, that's a good point because Just like the array languages, our Bye Hello World doesn't stress them where their strength is. Their strength is multidimensional arrays. We have no multidimensional array manipulation in Bye Hello World.
No.
So we're testing the features of the language that are not heralded as their strength. The strength of Erlang is the beam, the OTP, the supervisors, the concurrency. It's concurrency oriented programming. We don't have any of that in here. Yeah, in fact, they call it, a lot of people program in Erlang, they will call it concurrency-oriented programming. And then one of the things I notice and people should know, proglangcast is our cast for proglang base. Proglang base is a website that we're building it in Erlang, building it because of the concurrency and the fault tolerance and the scalability and the lightweightness and the elegance of it. That's the whole motivation to do that. And we're not doing any of those things here.
Right.
So we're not really showing you what real Erlang is like, other than if you have to do things that are fairly ordinary in other languages. Well, yeah, they're pretty ordinary here with the immutability added in, with the recursion added in, with the pattern matching. I would say that's probably, wouldn't you agree with that? Maybe the one thing that stands out most from other implementations so far we've done, except for F# is the pattern matching.
Oh, yes.
That's what's different here.
Well, and I think, like I said, I think it did a pretty good demonstration of the pattern.
Yeah, you demonstrated the pattern matching. We're seeing that.
In that sense, the only thing we're really not showing is the concurrency and the fault tolerance.
Which is the only thing, which is
well, here's what Joe Armstrong. Here's how he summarized the principles behind languages like Erlang. He said everything is a process. Processes are strongly isolated. Process creation and destruction is a lightweight operation. Message passing is the only way for processes to interact. So there's no shared state.
Yeah.
Processes have unique names. If you know the name of a process, you can send it a message. Processes share no resources. Error handling is non-local. And processes do what they are supposed to do or they fail. So
and let it fail. Yeah, let it fail is the phrase for Erlang. Let it fail.
That was
when I first heard that. Way of looking at it. I was exposed to Erlang again back in 2013, 2014, and I was talking to an IT guy, and I was watching. He was doing his thing, and I'm like, "Oh, the process failed." He's like, "Yeah, let it fail." I'm like, "What? Let it fail?" And I knew it was Erlang, and but I never made the connection of what that meant. It doesn't mean let the system fail. This is why buzzwords and phrases and platitudes can sometimes really work against us.
Yeah.
Is that we think they represent one thing and they're trite or oversimplifying. What it means is because you let a piece of the system fail, the overall system stays alive. Whereas everywhere else, you try to prevent anything from failing because if anything fails, the whole system comes down.
Right.
So letting it fail means, no, you're not letting the system fail. The system's staying alive. You're letting pieces of it fail in portions, and then some other part of the system is going to heal it and repair it or recover in some elegant way. So really it's don't let it fail. Yeah. Honestly, would be the proper phase for Erlang. We're not letting it fail. We're building in our fault tolerance at a fundamental level.
Yeah, and I think to get back to your question, I thought about maybe doing an Elixir. Should I try doing an Elixir version of this?
Yes.
Okay, and I'll try that, and I'll give you a better answer then. But my first blush looking at it was I didn't really understand why they had a problem with the syntax in Erlang. I mean, so when I look at the Elixir, I know it was what you said before. It was based on Rails, and I'll evaluate it. Maybe I'll go ahead and do that next.
As far as
want to do next,
I'm not sure. I've developed such a fondness for the array languages.
Yes. I thought you wanted to do something in Scheme.
I already did. I already did write Scheme implementations of Bye Hello World. It was so easy and quick. I just did a Racket, an S7, and a Shea.
If you've done some stuff in Scheme already, I think I'd like to see, because I'm interested in Scheme.
All right, so we'll do the interview with Bob next week, and then I'll present Scheme the following week. So that gives you 3 weeks to do something. I would like to ask, when you go to do Elixir, I think you should do a version of Erlang that involves the processes, because
I could spawn the run.
I think it would be nice to have a version of that, and then you could do the Elixir variation and even the Elixir variation of that and compare it. I kind of did that with APL. I went back and revisited APL, and then I said, okay, this now leads us into BQN to show you how the whole BQN thing looks. It's totally, so your thing, your way to do it.
Well, no,
But I think that would be nice.
I'll do that. And when I do the Elixir, I've got 3 weeks, like you said. So when I do the Elixir, I've got time. We can go back and look at a different version and talk about the Erlang version a little bit. And I'll look forward to seeing your Scheme version. But I also might think about doing a Gleam version too after I do Elixir. Why not? If they're all Beam languages, that might be something worthwhile to look at other Beam languages.
Well, there's a fourth Bing language too. It's a Lisp. It's LFE.
Yeah.
So Lisp flavored Erlang. And after you see Scheme, I'll present Scheme. You can decide how painful it is to look at a
Lisp flavored Erlang. That ought to be interesting. That'll be it for now. Thanks everybody for watching.
I wish you the best of luck.
Happy programming.